Yep. 1, 2, 3. Does it work? Yep. Hi everyone, thanks for coming. I'm Max from Google Chrome security team, and I'm mostly working on fuzzing of Chromium browser, its components and other open source projects. For those who maybe think like what I might forget in Open Media Room, I had an internship 5 years ago in Intel Corporation working on Media SDK. I've been trying to implement H265 encoder, and so I remember some stuff like macro blocks, variable length codes, IP frames, so I feel pretty comfortable in Open Media Room. And agenda of my talk, I'm going to briefly explain what is the fuzzing, how you can do it, how we do it at Google, why media processing projects seems to be a good target for fuzzing, and in the end I'll give an overview of OSS Fuzz project. It's like a fuzzing as a service for open source. Okay, let's start. Fuzzing or fuzz testing, it is also called so, is basically a pretty simple routine. You just generate some data, you use this data as an input to your target, you monitor your target for unexpected actions like crashes, some inconsistency, some security bugs, and you just repeat this process until you find some bugs, some unexpected stuff. Why fuzzing is good and why people use it? Together with memory tools, also called sanitizers, address sanitizer, memory sanitizer, undefined behavior sanitizer, and so on. It helps to find a lot of bugs, almost every type of memory corruption bugs, any other crashes like null derefs, uncaught exceptions, data races, like any stuff you may have in C or C++ written projects. All these troubles can be, not all troubles in the project, but all types of these problems can be found. And it also is useful for finding logical bugs, but it requires some smarter approach to your fuzzy target. I will show some examples later. And one more good point, it also finds not only crashes or breakages, it also finds hangs or out of memory bugs when you just, let's say you have 1 kilobyte video file and you try to decode it, and it takes 80 or 100 gigabytes of memory. It's definitely a bug, and it's also can be easily found with fuzzing. Speaking about fuzzing approaches, we can split it into 3 types. First one is generation-based, when you write some generator to generate data for your fuzzer, because basically you can read def random and feed it to your target, but it doesn't make sense in most of the cases. So you write something, let's say, HTML page generator. You just took all names of HTML tags and you generate some text based on these elements. Then you try to open page generated by your generator with a browser, and sometimes you will find some unexpected stuff in browser. Another approach is mutation-based. When you do not generate data, you already have some data, like you have valid video files, valid HTML documents, depends on your target, and you have some mutation engine which reads existing targets and mutates them, duplicates some parts, interlays them, everything which can be created and programmed. And another approach, it is stuff which we call like a modern approach. It's a guided mutation-based fuzzing. Mutation-based side part is already explained. Guided means that fuzzing engine, which generates inputs and mutates inputs, it tracks coverage of targets for every input generated. So let's say fuzzing engine generates some video file, it feeds it to decoder, and it sees which parts of code are covered. Then it mutates this input, generates another one, feeds it to decoder, and see if new coverage has been reached. If new coverage has been reached, fuzzing engine saves this input as, let's say, interesting one. If nothing new has been reached, it just ignores it. Due to that, you accumulate files over time, and your coverage grows over time. So if you're fuzzing for a, let's say, months or week or several months, you can get a pretty high percent of coverage of your target. How does it look usually? Let's start from the bottom. This just 3 lines. This is what fast target essentially is. You just need to write one function which has arguments data and size of data. That's it. And you use this data as you want. Usually you just feed this data into some target API to which you want to test. In this example, target API is some artificial example which has a bug. We are short on time, so I just disclose it. When size is 3, you have buffer overread, right? You have only 3 elements in data array, but you try to check element with index 3, which is like 4th element. And this example works in just 3 iterations. It finds this bug, but of course this is an artificial example. Another nice real-world example is our libxml read memory fuzzer. You can find it on GitHub, but it just has one call inside this fast target. It just calls XML read memory function, which basically just parse XML document from memory. And with that one-liner, we found about 30 bugs in libxml. For over last year, there were heap buffer overflows, user to free, all this stuff. That example of fast target is actually libfuzzer defined interface, and libfuzzer is an engine for guided in-process fuzzing. It is not the only engine in the world, but it is the one from which we started our project. It's actually a library which provides main, so you just write the function which you saw on previous slide. Then you compile your target with specific flags, which is basically some sanitizer tool, address sanitizer, memory sanitizer, depends on which build you are going to test. And you need to specify coverage type, which will be used to track coverage when testing different inputs. And that's it. When you write fast target, compile it, and run it over some corpus. Basically, you can start with empty corpus. Corpus is a set of inputs, set of test cases, initial test cases. If you have some, you better to put it into this directory because it will give some understanding of the target to fuzzing engine. But you can also start with an empty directory. It works. Why media projects are written in C++ are good targets for fuzzing? Basically because it has a lot of stuff working with raw memory, and if it's C++, it can be some logic with objects. And if you write it, you definitely know how many troubles you may have in this. And another point, because media processing is actually used everywhere, you know this better than me, because like any device with a battery and Wi-Fi connection definitely has several codecs and libraries for decoding media, and not only devices in this room, but everywhere. And due to that, media projects are definitely a target for attackers, and some most known cases from previous 2 years, 3 years. You've probably seen FFmpeg and 1000 Fixes article from guys from Google security team. I hope you heard about StageFright. It was a vulnerability in media library for Android, which allowed to hack Android phone just by sending a MMS message to the phone owner. Another example from 1.5 years ago is viral video. It was an FFmpeg vulnerability in parsing of playlists. So it allowed to read local files from the remote server on Facebook, on YouTube, just on every video hosting service in the world. Yeah, this is all links, so if you are interested, you can then open the presentation and read more. Another example from last year is Image Tragic. It was a bug in Image Magic library for image processing. It also affected Facebook, and you maybe recently heard that one guy got a $40,000 reward for reporting that Facebook uses vulnerable version of image magic, and it allows to execute code on remote server. And another example, the most recent, it's in Chris Evans' blog. It was a bug in GStreamer, which worked on Linux desktops. Basically, you download a file and open that directory, downloads directory in File Explorer. And usually you see a preview of the image, and this functionality of preview has been abused by Chris Evans, and he wrote an exploit to turn it to remote code execution. Yeah, just a quick note, we sometimes at Google and an open source project hear from some maintainers or programmers that their projects have been fast, but actually it doesn't work this way, because you know how fuzzing works is these techniques are changing, the project itself changes, and to get high coverage and to cover most of your project, it actually takes time. So the best approach is to make it in a continuous way. You just take new build every day or twice a day and fuzz on existing corpus at this build. And a good example just from the last week, a bug in OpenSSL. It took about 550 CPU days to find it. It was a very interesting bug because OpenSSL has two implementations to multiply big numbers, and it was a logical bug, which the fuzz target actually used data and its size as two big numbers, and then it called big numbers multiply, two different implementations, slow one and optimized one, and then it was comparing the results of this multiplication operations, and if result isn't the same, it was a problem. So this what has been found, it was carrier propagation bug in optimized implementation, which used almost everywhere, because when you do it, you want to use better, faster version. Yeah, now about OSS Fuzz. As I said, I'm from Google Chrome team, and we are doing fuzzing for previous maybe 6 years already, and we have a large infrastructure, about 15,000 of CPU cores to run fuzzers, to deduplicate crashes, to check fixes, and so on. So, like when you try to do it at scale, you will meet a lot of problem because some targets are crashing every minute, and you got thousands of similar bugs per day, and you need to understand which bugs are unique, which are not. And a few months ago, we just copied, cloned this infrastructure, and made it free and accessible for large open source projects on which, let's say, the modern internet relies on. Yeah, so this is all free. We have already more than 50 projects with about 200 fuzz targets, a lot of bugs found, and most of them already fixed. And yeah, we encourage every open source project to try fuzzing, to just try write a simple fuzz target to test your code. And if you can and would like join to this project, this would be awesome, because like all you need just to write these fuzzers for a target. All other issues are handled by existing infrastructure, and essentially it's fuzzing as a service, and it is free. Yeah, here I have an example of bug found and filed by our, we call it cluster fuzz. It's the whole infrastructure, it's cluster fuzz. And it is a real example from FFmpeg. Yeah, it has a type of bug, stack buffer overflow. It has a minimized test case to reproduce all the info like stack trace, configuration, which memory tool has been used. And of course, for security bug, they are accessible only by people you specify, your security team, or maybe you and other developers. It's not open until you fix it. Yeah, and also it's not only files bug automatically, it also verify fixes. Like this is the same example. The maintainer, maybe he's here, Michael, I don't know. he wrote that patch applied and like thanks. Then one guy from Google said that cool, and if everything is fine, cluster fuzz will mark it as fixed and close the bug. And then even the same day, cluster fuzz has detected this issue as fixed and closed the bug. So you just like you get bug, you fix it, and you shouldn't do anything else. Yeah, we also have some stuff to help you. I'm sorry you don't see it, but it is not very important to see. It's a statistics dashboard. It has some numbers, some percents for every fuzzer, such as number of test cases executed in given time range, coverage by functions and by code edges. It has links to coverage report. I will show an example on the next slide. Speed of generating of inputs, links to corpus, which grows over time. And there are a few more columns like performance analysis. I will also show an example. So you get analytics for your fuzzers also. An example of coverage report for another FFmpeg fuzzer. You don't see probably these lines, but you also shouldn't. These are different source code files and percent of code coverage in every file. If you click on file name, you will see more detailed view, like which functions have been covered and even which lines are covered and which lines are not covered by existing fuzzing corpus. Yeah, another feature is automated performance analyzer. It checks your fuzzer logs every day, and if your fuzzer has some issues, basically a set of issues is not big. It's known issues every time. Your fuzzer can be crashing every time like you run it, and it crashes in 5 seconds. So it doesn't work technically, and you need to fix it as soon as possible because you just waste CPU cycles. And there are other issues which are similar for some fuzzers. So this performance analysis let you know them without checking logs for hundreds of fuzzing runs which are happening every time on the infrastructure. Here are links for looking at other examples of fuzz targets in Chromium in existing OSS fuzz projects. We actually have only FFmpeg in OSS fuzz. So if you are working on other decoding projects, or I don't know, VLC player, I see a lot of guys with heads. You are super welcome to take a look at it, to ping me, and we definitely should work something out on that. And I've seen that GitHub already has a lot of fuzz targets for, I don't know for which projects, like, but there are thousands of them, and it's also a great place to take a look. Yep, that's all. Thank you very much for your attention, and I would be glad to answer any questions. Oh, yep, sorry, a minute of promotion. I'm giving a libfuzzer workshop in April in Munich, and if you manage to be there, please come.
Yeah, so we have one first question there,
yeah.
Another one here. So we've been doing specifically H.264 fuzzing in our company for many years now, and we actually pushed all the tools to the mailing list and stuff, but it was never merged. And we think your tools are not very good and your corpus is very good, not very good, but I don't see how on GitHub we can improve that, because you use the test case, you use the regression testing thing as your corpus, which is okay, but you don't test the full range of features in the decoder. You only test essentially the default features and not more obscure features like slice threading, interlacing. So, and I haven't quite understood how on GitHub you can add more test cases and add more features, more test things in the programs. We already have this, but we'd like to do it, and I don't understand. Could you explain how to do it?
Yep. So the question is how developers, maintainers of project can affect what we do at OSS Fuzz and can add some complications to fuzzer or inputs and so on. Well, basically our idea is to move responsibility for fuzz targets and for corpus to developers. Actually, we are trying to do not own fuzz targets, do not own this source code of fuzzers. For FFmpeg, we initially had one fuzzer in Google internal stuff, and this fuzzer supports about 60 different configurations. So we just pushed that fuzzer to FFmpeg repository, and then FFmpeg guys helped us to, let's say, integrate it in our existing pipeline. So if you have something to improve, the best way is to do it to push it inside your target repository, FFmpeg or another one.
But they pushed yours. I did, but they pushed yours instead. That's what
we should find those guys who rejected your pull request and ask them why this happens. You're also welcome to create a pull request on OSS Fuzz. And
I don't understand. It's not clear at all on OSS Fuzz where the corpus is stored, because all you seem to do, as far as I can tell, is you just do a pull. You just pull off the test suite, but where are these files stored? How do I upload files to GitHub in the corpus? It's not at all clear at this point.
We store corpus in two places, even in three places. First of all, you can upload it just to OSS Fuzz repository and add one line to build a such script there. Another way to store it in target repository of your project, but again, in build.sh script in OSS Fuzz, you need to copy these files to output directory. And third place is a cloud storage where we run Fuzzers on different machines, and all of them are syncing files to common place. And project maintainers have access to this common place, and they can download existing corpus, they can drop new files in there. So if you are not maintainer of the project, you don't have access there. But if you are maintainer or developer who is responsible for bugs, you have access there. And it is written somewhere on OSS Fuzz page, but yeah, I agree that it's probably hard to find. Thanks.
So I have a second question there.
I'm new for the fuzz test, but is the fuzz test just generating the random input and trigger some runtime error, but not using this random input to trigger at the unit test that is based on the project?
So the question, if I got it, like fuzzing engine generates inputs and feeds them to the target to get runtime errors, but doesn't feed it to existing unit tests,
Yeah.
right? Yeah, but essentially it's somewhat similar to unit testing, but it is better because like in unit testing you have some input, test input, some functionality, and some expected output. That's it. In fuzzing you only have this functionality, and you do not have a specific output. You have millions of them, they are generated. And you also do not have any output. You can have, if you want to do some correctness checking, if, as an example, this open SSL multiplication. But technically, basically, fuzz target is a unit test, but continuous unit test without fixed input and output values. And we are trying, in Chromium, we are trying to convert existing unit tests into fuzz targets to have them as an enhancement. Like we would like to have unit tests because people write them and they are really important. But copy their functionality which they are testing into fuzz targets and do it in continuous way is great because it finds a lot of stuff.
Okay, thank you. The third question here.
Thank you very much for the talk. It's very interesting. So I'm part of a research team in Imperial College London. We've been working on fuzzing graphics drivers, and actually we can crash the machine through a simple WebGL page, including on Chrome. It's really interesting. And so about the question is more like, do you test, so this is more about all media processing. Do you also test graphic drivers or just drivers in more general? And I would be interested to know, you mentioned 50,000 cores. Is this what you offer to other people to do fuzzing, or do you have even more cores dedicated to fuzzing inside Google?
Yeah. Let me start from the end. The question is about number of CPU cores, which we are using. 15,000 of cores, it's internal Chromium infrastructure for Chromium browser. For OSS Fuzz, we have, let me do not lie to you, maybe 4,500 CPU cores at the moment, but we add more when we are getting more projects. And the first question was about fuzzing not only media projects, but drivers, graphic processing stuff. Yes, we have some of them. You can go to Chromium code search, like Chromium code search, and look for GPU Fuzzer.
Okay.
You will find there an example or maybe two of existing GPU Fuzzer. Yep.
Okay, last
Thank you.
question. Okay, last question.
When the project gets something, it automatically loads the bulk within Chromium